So now let us do examples. We have here f of x equal to 1 over root x minus 2. The question is find the domain. Find the domain of definition of the following functions. So we have f of x to 1 over root x minus 2. So here 2 is even number. So our dom f, we're going to say that x is a member of real number such that x minus 2 is greater than 0. It is only greater than 0. So now here, which means that we let x minus 2 to be equal to 0 in order to get the values of x. Our value of x there is 2. So after that, we start the sign. As we're studying the sign, we have x from negative infinity to positive infinity. There we have 2. And our equation is x minus 2. We'll get 0 here, and here it will be minus plus. So it is greater we have, it is where we have positive solution is. So meaning that our x domain, I'm going to say that dom f, x will be a member from 2 excluded to positive infinity. So that is our domain. From 2 excluded to positive infinity. So let us see number 2. The same question asking for a domain. Let's say if you have f of x equal to 1 over cube root of x minus 2. What can we say? What can be the condition? So here, our condition is dom f, x is a member of real number, which is domain of definition, such that x minus 2 is different from 0. Because to get the cube root of x minus 2, there is no condition. The condition is only that because this value is on denominator and it has to be different from 0. So meaning that our x is different from 2. So domain is a real number except 2. That's domain. Or we can say dom f is from negative infinity to negative 2, excluded union from 2 to positive infinity. Okay, from there we can see another function like when f of x is exponential function like a power x, where a is a constant. Exponential functions like f of x equal to a power x. So for f of x equal to a power x, and that is exponential function, domain is real number. There's no condition there. Domain is real number. Domain is real number. Because if you have f of x, for example, let us see examples. Let's say that we have 2 power x. Find domain of definition. Domain of definition of that function. Of the function. So how are you going to find domain of that? 2 power x. X is like a polynomial. So on x there is no condition. So our domain there is real number. That's the answer. Okay, so let's go to logarithmic function. For the function is logarithmic function, for example, like f of x equal to logarithm of u base a. Logarithm of u base a. So dom f, x is a member of real number such that u is greater than 0, then a is greater than 0, and also a is different from this. A is between 0 and 1. So where this a is constant, let's start with where this a is constant. Where a is a constant. Is constant. Let's say this base is constant. If a is constant, it will not ask for a condition, because if this, the function is u, so u must be greater than what? 0. For example, find dom f of x equal to logarithm of x plus 2 base 3. Domain here, dom f, we say that x is a member of real number such that x plus 2 is greater than 0, because there is no logarithm of a negative number. There is no logarithm of a negative number. So we let x plus 2 to be equal to 0, x will be negative 2. And if x is negative 2, we start the sign from negative infinity to positive infinity. We have negative 2, and our equation is x plus 2. So it will be 0 here, negative, positive. So dom f, we say that is x the member from negative 2 to positive infinity, because that's where you have a positive solutions. So that's the domain. Okay, so let us see like another example, just one example. So that was like number 2. Let's say f of x equal to ln of x plus 3. ln of x plus 3. How can you find domain of definition? Find domain of definition. How can you find domain of definition of that? So our dom f is said that x is a member of real number such that x plus 3 is greater than 0. That's the condition. So as you start the sign, dom f will be, x will be a member of real number from negative 3 to positive infinity. That will be the answer. So let us go to other parts. I think you don't have any question from here. So let us go ahead. So now let us proceed. We are on composite functions, and you're still with teacher King David. So here on all composite functions, when you have f of x, like f of x equal to maybe to 3x plus 2, and g of x equal to 2x plus 1. And they can ask you to find fg of x. That's A. B, they ask you to find the gf of x. C, they ask you to find g of 2. D, they ask you to find fg of 1. E, they can ask you to find gf of 2. How can you find that one? That's what we call composite functions. So now we have like fg of x, like fg of x. You see where there was x in f of x, so we brought g of x. So meaning that I have to go in f of x, where there is x, I put there what? G of x. Simple as that one, plus 2. Because if it is fg of x, before it is fg of x, it was f of x. So where there was x, now I have g of x. So meaning that I have to go in f of x, where there is x, I put there what? G of x. Now, f g of x will be equal to 3 into bracket g of x. What is g of x? 2x plus 1. Then plus 2. So which means that f g of x, the answer is 3 times 2x, 6x. 3 times 1, that is 3, plus 2. Implies that fg of x equal to 6x plus 5. So now, what is the fg of 1? Fg of 1. So where there is x now, I have 1. That is 6 into 1 plus 5, where fg of 1 equal to 11. So this is D, answer for D, and this was the answer for A. So let me go to B to do B. Our B is saying gf of x. So meaning that I have to go in g of x. What is g of x? It is 2x plus 1. Where there is x, I put there, that is 2 into f of x plus 1. So now this is 2. What is the value of f of x? The value of f of x is 3x plus 2. Then plus 1. This is 6x plus 4 plus 1. So gf of x equal to 6x plus 5. 6x plus 5. Then C. Let me first find E. E, they're asking gf of 2 because you have gf of x. Gf of 2, it will be 6 into bracket 2 plus 5, and that is 17 because it's 12 plus 5, which is 17. Then let me go to C. C, they're asking g of 2. And remember, g of x equal to 2x plus 1. So it will be 2 into 2 plus 1, where the answer is 5. That's g of 2. So let us see like example number 2. Example number 2, it is saying we have f of x equal to x minus 4 squared minus 1. For x is a member of real number, find fg of 4 where g of x equal to 2x plus 3 divided by x minus 2 for x is a member of real number such that x is greater than 2. Okay, we have f of x and we have g of x. The question is to find fg of 4. Before we find fg of 4, let's first find fg of x. What is fg of x? So I just go where I have f of x. Where there is x, I put there gf of x. I go in f of x. Where there is x, I put there g of x. So now in f of x, it will be into bracket. So where there is x, I'm going to put there g of x minus 4 squared, then minus 1. Okay, so what is that? This is, what is g of x? 2x plus 3 over x minus 2. That is g of x. Then minus 4 into bracket squared minus 1. So this is fg of x. So we're just remaining to find the LCM and we make it as one fraction. But since they're asking only fg of 4, immediately we can do fg of 4, which is into bracket 2 times 4 plus 3 divided by 4 minus 2, then minus 4 squared, then minus 1. So this is 8. 8 plus 3, that is 11, divided by 2 minus 4, into bracket squared, minus 1. So we find the LCM there, that is 2. 11 minus 8 squared, minus 1. So that is 11 minus 8 is 3. 3 over 2 squared, minus 1. Which is 9 over 4 minus 1. LCM is 4. We get 9 minus 4 over 4. So meaning that fg of 4, the answer is 5 over 4. So that's the answer. I hope you don't have any question from there. So this is the same as 1 and 1 over 4. I hope you're understanding. Let us see other examples, or we immediately go to inverse of the function.